Hi guys, my name is Peter C. Dogba Jr., mathematics instructor at the University of Liberia and your math tutor. In my today's video, I will be discussing differential equation, and under differential equation, I'll be looking at verifying differential equations. So given that this is a differential equation, and assuming that this is this is a solution to this differential equation, we were asked to prove or to show that this is actually a solution to this differential equation, or to verify that this is a solution to this differential equation. So to prove, to show, to verify, they all mean the same thing. So let's go ahead now. So I'm not going to use the integral method again. I'm not going to use the two methods. I'm going to use one method to solve this problem, and to solve the rest of the other problems, I'm just going to use one method because it's very easy. So this is the problem. This is the solution that was given to us. Y equals x e raised to the power x. Look within the problem. This is the problem. This d2y dx squared simply means y prime prime, because the function, the dependent variable here is y, which is the name of this function, and the independent variable is x, the variable within the function. So this notation represents second order differential equation. So we can rewrite this as y prime prime minus 2. So this is also just a derivative notation. This derivative or differential. So we call this y prime because it's the first derivative. And then plus y all equals to 0. So with this idea now, we know our y, which is this. We need to know our y prime. So we differentiate this. Y prime equals. Now we have two functions. So in our video on the product rule of differentiation, we told you that whole one of the functions constant without differentiating, and you differentiate the second function. So given that y equals to e raised to the power x, the derivative dy by dx, let's say y prime now, which is the derivative of y, is just equals to the same e raised to the power x. So we hold x, we differentiate e raised to the power x is the same e raised to the power x, plus we hold e raised to the power x now, we differentiate x, it gives us 1. So if you having some issues, you can review our videos on the differentiation, methods of differentiation. Now we can simplify y prime is equals to x e raised to the power x plus e raised to the power x. So wheresoever we see y prime, we're going to replace it with this one. Wheresoever we see y, we replace it with this one. What do we need again? We need y prime prime. So y prime prime. So we differentiate this one, the same thing. We hold x and differentiate e raised to the power x is e to the power x, plus we hold e raised to the power x and differentiate x now, it gives us 1, plus we differentiate e raised to the power x, it just gives us the same e raised to the power x. So y prime prime is just equal to x e raised to the power x, plus, now this is just e raised to the power x times 1 is e raised to the power x. So this and this are like terms, you have 2 e raised to the power x. So we can now replace each of them now within the differential equation. So the first one is x e raised to the power x plus 2 e raised to the power x minus 2 times y prime is just this one, x e raised to the power x plus e raised to the power x plus y now is x e raised to the power x all equals to 0. So we simplify. Now this is x e raised to the power x and x e raised to the power x. So this gives us 2x e raised to the power x plus 2 e raised to the power x minus 2 times this is 2x e raised to the power x, and then 2 times e raised to the power x is minus 2 e raised to the power x all equals to 0. So what do you notice? 2x e raised to the power x can cancel 2x e raised to the power x, opposite signs. 2 e raised to the power x minus 2 e raised to the power x. So you have 0 equals to 0. So you have been very far since the left hand side is equal to the right hand side. You have now been verified that this solution, sorry, I'm using the word particular. I actually don't mean that a solution that was derived from the general solution. I actually mean this given solution. That's what I'm calling particular solution. So this given solution is actually a solution to the differential equation. So thanks so much for watching. See you in our next video.